get change of variables done today. I wish I could spend tons of time on lots of things, including this, but we can't. So here is a version of 9. I'm going to set up the thing till we get to the point where the change in variables, the du, dv bit is up, and then from there we'll probably just move on. So we're doing this double integral. They describe the region R as being the intersection of these two straight lines and these two hyperbola, right? So imagine there's a line going like this and a line going like this and a curved guy going like that and a curved guy going like that. If you wanted to see it, you could certainly put it into Desmos. It's like a curved rectangle, right? Can you imagine a rectangle where two of the lines were kind of straight and two of the guys were curved? Really weird looking shape. Not easy to set up limits of integration uses x's and y's, and that's why we're going to use this technique. Well, it's not clear the way they've written it down, so I've deliberately put some lines here. Here is the u sub. I'm calling it u sub. Here is the change in variable. So the Jacobian. And it's, there we go. Be a miracle if I get through today without making 100 mistakes, but I'll try my best. Okay, there's the Jacobian set up. If you differentiate this with respect to u, you get 1 over v. If you differentiate this with respect to v, you actually get negative u over v squared. Can you trust me on that? You call that uv to the -1, that's what you get. Now, if you move on to this one, this is much nicer. If you do this guy with respect to v, you get nothing, and here you get 1. So major take away minor is 1 over v, take away nothing, so it's 1 over v. Little side point here, but it was brought up by one of our students. In some of the earlier questions, they only ask you to find that, in which case the answer might be negative. But whenever you do a Jacobian in an integral like this, it's always the positive value. So if this is -42, this becomes +42, right? So if they don't have the little vertical lines around it, and you're just being asked to find Jacobian and nothing else, then you could get a negative answer. But if you're finding the Jacobian in any other context, we are doing absolute values. Of course, when the thing's an expression, we just have to assume that it's fine. I mean, you can't really stick an absolute around that. Well, that's that guy done, right? A little circle to remind you. Now, limits of integration and changing this guy. Let's change this guy. The function f of xy in this case is 3xy, and that becomes 3 times x times y, which is actually quite nice, right? That came out good. And now we need to do the limits of integration. So I have this guy here, right? And maybe I should switch places because I need room. So I have y equals 2/3 x. And y is going to be replaced by v. And 2/3 x is going to be 2/3 u over v. And a little cross multiply, v squared equals 2/3 u. Okay. And if we do y equals 3x, v equals 3 over v, so v squared equals 3u. And if we do xy equals 2/3, then x is u over v times v equals 2/3, which gives me u equals 2/3. I like that one at least. And then if you do xy equals 3, u over v times v equals 3, and I get u equals 3, so I like that. So far, so good. Now, I want to find limits of integration, so I have to figure out a little bit more about what the values and what the limits of integration are. Well, I'm happy with the u's. They came out really nice. I'm not so keen on these guys, but I'm going to make the assumption that they're positive, and I think that's reasonable to assume. And if you do this guy, why am I not getting the answer I want? Oh, it's here, that's why. Got this one and this one. And so the V's are going to go from here to here, and I'm assuming that we have a big guy and a little guy, and this guy is the square root of 3u, which is bigger than 2/3 u. And since u is positive, can't I assume that, you know, well, I'll assume that they're positive. So I have my limits of integration. U is going to go from 2/3 to 3, and V is going to go from this ugly guy to that ugly guy. F of xy is 3u. The Jacobian is 1 over v, and then we're going to go a dv and a du. There is your double integral where everything uses u and v. And it's not pretty, but it works. And there are going to be some logs in it. Wait a minute, better keep that on 2 separate pages. Anything about that process that was too quick or unclear? I think that went smooth. I don't think they should have too many issues. I think this went smooth. Would you agree that the limits of integration were a bit ugly? And those two came out nice, right? U is 2/3 and U is 3. That was nice. What was a little bit less obvious is the V, right? The V squared has to become a V value. And I had to make the assumption, I guess it's an executive decision, that these are positives. And so if you take the square root of that and you take the square root of that, and that's where those two guys came from. And I can certainly say that that is typically bigger than that for any given value of u. That's why I know this is a big one and that's a small one. Yeah, calling that good then. Well, got a few more to try out. What's this one like? Yeah, well, the more we should do, they're all equally ugly. We're doing a double integral of r of a function called 2y squared. I think I should just invite the guys in and they could teach the class. They're close enough now anyway. R is made up of two curves. On one side and two other curves. Sorry about that. X, y squared, x, y squared. And one of them 6 and one of them 8. And the transformation we're going to use is this guy. At last, one that's easy. Xy squared is 6. Since xy squared is v, isn't that v equals 6 to v equals 8? Xy is 6, xy is 8, and u is xy, so that makes that one. Actually, aren't the limits of integration really nice in this question? I really didn't need to do substitution and tidying up. I mean, it's pretty clear to me what they would be. I'll do the Jacobian now. I don't know, I keep wanting to say come in. Okay, if you differentiate this guy with respect to, what have I just done here? Oh, I know what I've done. These two equations are not written as x equals a function of y. X equals a function of u and v, and y is a function of u and v. They're actually written the other way around. So I'm going to do a little trick. I'm actually going to find this guy. So I'm going to do differentiate with x, differentiate with y, take v, differentiate it with x, and then differentiate v with y, which is not what I want, right? I want the other way around, but I'm going to calculate this first, and we'll see another sneaky trick. That gets you y, and then it gets you x, and then you do this one, you get y squared, and then you do this one, you get 2xy. And so major diagonal is 2xy squared. And going this way, you get xy squared. And if you pull out an xy as a common factor, you get, what's that? An xy squared as a common factor. Oh, I don't need 2xy squared as a common factor. You get 3xy squared, don't you?
No.
No.
It's supposed to be subtraction.
Keep with me, this distraction is even worse than my usual mistakes. Right, you get xy squared. Now, there are two things that are wrong with that. First is, the answer doesn't have u's and v's in it. And secondly, that's not the guy I want. The guy I want is this guy, right? Well, let's take care of the first problem. Xy squared, isn't that what v is equal to? Right? Now, can you remember? Can you remember that I told you that you have a connection between this fella and that fella? What is the connection? What's this guy equal to in terms of this fella?
Reciprocal.
Yeah. So it's 1 over that guy. So calculating this guy was pretty easy. And so it now ends up being 1 over v. Do you see that I've actually got the Jacobian in a kind of roundabout way? I didn't try and turn this into x as a function of u and v and y as a function of u and v, although actually I could have done it if I wanted to. I think that was a little bit easier. So I have got the limits of integration. I have got the Jacobian. The only other piece of the puzzle that's missing is the function, which is this guy, turned into u's and v's. So it's 2 times, okay. I need to find out what y squared is. So here we go. I'll call this equation 1, I'll call this equation 2. Any ideas how I can find out what y is in terms of u and v and having no x's involved? It involves just one calculation to do that.
Would you subtract them?
I wish a lot of times that would work, but I'm not going to subtract them. But I'm going to divide them. Well, I get u over v, which is okay. The x's cancel and one of the y's cancel. And I can do this a couple of ways, but how about simply just switching everybody upside down? Would you agree I now have y in terms of u and v? So this guy now becomes that guy, which becomes that guy. So I've got the function, I've got the limits of integration, I've got the Jacobian. You put the package together and you're finished. So you're going to do, well, let's figure out what the function is. The function was this guy times 1 over v, right, the Jacobian. I guess I'll do uv, and u goes from 6 to 8. So does v go from 6 to 8. Yeah, a little tidying up there. Would you agree you could cancel one of the v's and separate it out and you're done? Any questions about that guy?
Why does the limit go to, is it 0 or 6 down there?
It's 6 to 8 in both cases.
Okay.
And I just basically noticed that these two guys were u and v. So these limits became u was 6 and 8, and these limits became v is 6 and 8. So it's kind of nice that we got that, because normally wouldn't you have to replace all of these guys with u's and v's and then, you know, generate the limits of integration from there. Where are we going? We've got about 2 or 3. Well, we should get them done. At this point, up to this point anyway, you've always been told what the substitution is going to be. So let's make life a little bit harder. And think about that guy. And the region R is described as a parallelogram made up of 4 lines. And here are the equations of these 4 lines. And we need to do a change in variable. We need to pick a u and a v. There are lots and lots of clues here to tell us who a good u and v would be. I typically tend to look at what's going on here. Any suggestions for what a natural value for u and v should be?
U should be x minus 4y and v 7x minus y.
Does that seem reasonable? And it is. You just were a bit hesitant, right? So since I'm calling this guy u, doesn't the limit of integration just become 0 to 3? Okay, that's u, so 0 to 3. And won't this one be v equals what, 9 to 10? So hey, we got the limit integration almost without trying. Agreed? Now, let's figure out what the value of the function is. So in this case, it's going to be 5 lots of x take away 4y over 7x take away y. Well, doesn't that become 5u over v? You agree that also transfers really nicely. And since I've got the u and the v, the only piece that's kind of missing now is the Jacobian, and this one should be over with. There I go again. That's the guy I want, agreed? Now, I could spend some time finding out what x is in terms of u and v and finding out what y is in terms of u and v, but can't I use that trick again? Agreed? So now I can use this fella. I'm going to find the Jacobian the other way around, and then just take its reciprocal. Okay, differentiate with x, you get 1. With y, you get -4. With x, you get 7. With y, you get -1. Major diagonal, -1. Take away -28. I believe you get the answer +27. So the Jacobian is 127. Are you comfortable about this trick where if your substitutions are in terms of u and v rather than x equals and y equals, you can do this little sneaky way around. Right, all the pieces together. U is going to go from 0 to 3. V is going to go from 9 till 10. The function is 5u over v. The Jacobian is 1/27. And then you do a dv and a du. And at that point, you're back to a usual kind of boring double integral, which is variable separable as well, which is nice. Any questions? I know I'm kind of zooming through these, but the more we do, I guess the more practice, plus you can always go back and look and, and pause and stop, and all that good stuff. Are we good? Okay, next one coming up. Doing a double integral over a region R. It's 9x plus y's e to the x squared take away y squared. And the region R is described by parallelogram of lines. And the equations of the four sides are these lines here. And again, we need to figure out who is U and who is V. I think this one should be easier than the first time I asked you, because if you look, it's into a very similar situation. Agreed?
X minus y and x plus y.
Yeah. And so this ends up being U goes from 0 to 3. Oops. And this is V goes from 0 to 10. So don't we have our limits of integration for U and V? Check. We have these guys. Well, that's good. Let's focus now on this ugly mess. Now I can tell you who x plus y is, so that's the easy one. You might think that this is going to involve a lot of work, but actually it's not that much work at all. Because isn't x squared minus y squared an x plus y times an x minus y? Agreed? And that means that this guy is e to the, technically, that's a v and this is a u, so make sure I got that the right way around. VU, right? I'd probably call it UV, but there's our XY. So we got the limits of integration. We got this guy. We need a Jacobian, don't we? And then put the pieces together, we're done. Aren't we stuck with that turn me upside down trick again? So I'm going to just write it down straight off the bat this time instead of rubbing it out and then putting it back in. I'm going to find that guy. You get a 1, you get a -1. You get a 1 and you get a 1. You get 1, take away -1, you get 2. So the guy we want, the real Jacobian, that one, is 1 over the guy we found. And so it's a half. So when you put all the pieces together, U goes from 0 to 3. V goes from 0 to 10. The function looks like that guy. The Jacobian is a half. We have that. I would pull out the 9 over 2 outside. Why didn't I do this as a variable separable, even though we've got numbers on the limits? Why can't I separate this one? What's the bit that's causing the trouble?
The E.
E to the UV part, right? So you just, sometimes you don't get it. I'd love it to have a variable separable component, but it didn't have it. I'm too quick. Was there any questions with that one? The more of these you do, that's why I'm kind of rushing. I want to try and get as many under the belt as I can. Would you agree, the more of these you do, it's easier to see what you're going to do the next time, right? You've got a kind of goal, right? You got to get these guys, right? You got to get limits of integration at least, right? You got to turn this guy into using V's, and you got to get the Jacobian. If you can find this guy, and this guy, won't you always get an answer, right? You'll always be able to get it down to the stage you need. Moving to, well, got time. I think we'll make it. Okay. This one might not look like the last two questions, but it's actually a lot closer looking than you think. You wouldn't want to do that integration, trust me, right? Even before you see what R looks like. And R is all these points joined up. So 2, 0. There you go. 10, 0. Not 10, 0. 0, 10. 10, 0. Doesn't make sense. Let me check that. 2, 0, 10, 0, 0, 10, 0, 2. I'm trying to join those up. Oh, there we go. Darn it. I'll be lucky to tell you what my real name is. Let's start. Make sure I've got all the points. There is my 2, 0. There is my 10, 0. So I'm going that way. A little arrow just to remind myself. I'm then going to go to 0, 10, which is up here. I'm then going to go down to 0, 2, which is here. And then I'm going to cross that way. There, can you see the region R now? So far, so good. Right, now, we are going to take this region and we are going to find out what the equations, what the thing is. But before I do that, I need to know a U and I need to know a V. that's not much help. This is. What you gonna do? Go for the obvious, because it is the right thing to do.
Would it be y minus x and y plus x?
In a perfect world, shouldn't that be the most obvious use of to do? Agreed? It is right. It's the right use of. Right? Does it kind of make, I'll make this up. Suppose the top line said xy cubed plus 7 and the bottom said xy. I would make the top u and the bottom v. Right? That would be my first go-to guy, and probably 9 times out of 10 it would be the right go-to guy. Now, that fella there, right? This region R, which is all in terms of x's and y's. This is where things get a little bit different. Doesn't that have to be transformed into a relationship using u's and v's? So that's where I'll now kind of kick in. So this shape is basically made up of 1, 2, 3, 4 straight lines. Would you agree? So for no particular reason, I'm going to give them letters or something, right? That line's A, that line's B, this line is C, and that line is D, right? So when I say A, I'm talking about that line there, right? I want to move this out of the way for a minute. Let's find the equation of the line called A. What's the slope of A?
-1.
And would you agree it passes through the y-axis at 2? So would you agree that's its equation? Okay. Now, I need to turn this fella into u's and v's. Great. So I'm now going to have to, now that I've realized that I have a little bit more work than I thought I was going to have, I'm going to take this equation 1 and this equation 2, and we are going to work with them to see if we can get x and y in terms of u and v. All right, looking at these two equations, do you think dividing them or adding them? I think I have a train on the roof now. If you add those two equations together, you get u plus v equals 2y. So won't that make y a half u plus a half v? Are you comfortable about how by just essentially adding them together, the x's cancel, right? And I get 2y and then divide by 2. Now, I still need to find out what x is. How could I find out what x is equal to in terms of y, u and v?
Subtract them.
I never thought of that, but that is actually would work. So I was just going to substitute it in, but I kind of like subtraction. So let's try it out. Yeah, why not? And if you take, it's a bit messy, but that's fine. If you take this guy, take away that guy, you get u take away v, and that guy take away that guy gets you -2x. It's not the worst thing in the world. That gets you -a half u plus 1/2 v, and that equals x. And we got the two done, guys. Now that I've got them, let's return back to this fella. The y is going to be a half u plus a half v, and the x then is, well, it's a negative of it, is going to be -a half u plus a half v add 2. So I have a half u plus a half v is a half u, take away a half v, add 2. If you subtract a half u from both sides and add, you get v equals 2. After all that hard work, we now have v equals 2. So that line gives me u equals 2. Are we good? Now, do you know there's 3 more lines? And I am running short of time. So can I tell you that when I do line C, that I end up with, and I'm just copying this one here, I end up with u equals 10. That's from line C, but you can check it. If I do line B, which is just a horizontal line, you end up getting, what did they tell me? You end up getting u equals negative v. And if you do the other line D, you end up with u equals v, or vice versa. So that's that guy taken care of. So we have limits of integration where u goes from 2 to 10, and the other 2 lines give you u v. Is that u is v?
Would A be v equals 2 instead
Yeah.
of u equals 2?
That's it. There we go. And v equals. It's quiet, so I'm going to try and do something quickly before I lose the space. There we go. There's our limits of integration. That's fine. I need to know what 9 cosine of y take away x over y add x is. Don't need the rest. And that's going to be 9 cosine of u over v. Okay, that's that done. I want to find what the Jacobian is. Well, since I've already spent all the hard work doing this, I might as well use it. Okay, you do this guy here, and you get negative a half, and you get plus a half. You do this guy, you get plus a half, and plus a half. That's negative a quarter. Take away negative a quarter is negative a half, but we know Jacobians need to be positive. So I finally got one where making me positive actually happened. So I should have all the pieces. So this guy becomes v from 2 to 10. And u goes from negative v. Yep, there's definitely a train on the roof. 9 times the cosine of u over v times a Jacobian, which is a half. And this is u first, and then there's v second. So I'd probably pull out the 9 halves. And our integral looks like that. We'll do 9. When you do the integral of the cosine of u over v, when you integrate it with respect to u, it's actually not that bad. So if you integrate the cosine of u over v, you get the sine of u of v. What else do you get?
V.
You get v.
Yeah.
You get 1 over v, which is v. And then you evaluate it at u equals negative v and at u equals v, which is not pretty. That's what you do. And then you could do the integral from 2 to 10. I just want to take this a little bit further. Right, so if you plug this in, what do you get? You get v, the sine of 1, take away, what's the other one? Negative v. V, the sine of -1. Wow, quite weird. Aren't these just numbers? Sine of 1 is not anything special. It's just a horrible decimal. And that might explain, let's have a look at the answer. That might explain, oh, my answer is slightly different. Because there's a multiple there, right? That's fine. But you just get a weird answer with sine 1s in it. Oh, does anybody know what the sine of -1 is connected to the sine of 1? Because they are connected. So I might as well do that while I'm at it. Isn't the sine of -1 the negative of the sine of 1? So basically, these two guys can be added together. And that looks even nicer. Oh, and the 2's cancel. This just keeps on giving. And isn't sine of 1 actually just a constant? So, cool. That one actually came out a lot nicer than I thought it was going to. Okay, last one. Which one am I picking? Am I picking 14? I'm picking 14. I'll take this until kind of time runs out. I'm pretty sure I won't get it finished. But we have a double integral over a region R. It's going to be 8 times the sine of 9x squared plus 100y squared dx dy. And oh, we have a 9x squared plus 100y squared equals 1, which is essentially an ellipse, and that's the region R. Okay, this one you could guess for a long time and maybe not get it. And I'm sure there's more than one substitution that would work, but they don't tell you, do they? No, they don't tell you what it is. That's the substitution that we're going to use. And is that shouldn't be 3. I take that back. That should be 10. Yeah, that makes much more sense. Well, let's show you what the region R looks like. It's 9 times, well, if I call it this guy, but if you rearrange it, isn't it 1/3 u? And if you rearrange this guy, x is 1/3 u. And if you rearrange this guy, y is 1/10 v. So 9x squared becomes that guy. 100y squared becomes that guy. And that gets you a 9th, and they cancel, and you get that guy. Can you see why I chose 1/3 u and 1/10 v? I could have chosen all sorts of things. I guess I could have chosen 1/3. Wouldn't work. No, I changed my mind. That's the only one I can think of. Of course, that does mean that this turns into a circle, which is fine. Which means I'm also going to have to introduce a polar then, aren't I? Okay. Now, what does this guy look like? Well, 8 the sine of 9x squared plus 100y squared turns into 8 the sine of u squared plus v squared. Will you just trust me on that? But you can do the math later. So far, so good. In this version here, isn't the Jacobian going to be pretty much what you see is what you get? So to speed it up, that's a 1/3, then it's 0, that's a 0, then that's a 10th. So basically, don't I get a Jacobian of 1/30th? I think I've got all the pieces. So we're going to do the theta from 0 to 2 pi because we had to change the polar. We're going to do r equals 0 to r equals 1. This guy here, where is he? Oh, here it is here. This guy turns into 1 turns into 8, the sine of u squared plus v squared, r dr d theta, and I forgot to add in my Jacobian, so I'll put it there. That guy cancels down to 4/15, and I'm going to pull it out. So it's not in the way anymore. What does that become in terms of polar r and theirs, or just r's? What's u squared plus v squared going to get me?
R squared.
Yeah. So we are going to be talking about that guy. And would you agree that this is a variable separable question? If you're up for it, Mia, will you tell me what technique I would use to integrate this?
U sub,
And the u sub will be
the r squared.
the r squared, right? And won't this just be 1, so you get 2 pi and you get an ugly fraction and you'll get whatever you get. Whew, that was well done, although I'm arrogant and say it myself. Because the only questions that are left are some videos that you can watch where you can see other, visual things that little videos, and it takes you through. It takes you through. I think we've got a dentist as well now. So it takes you through some examples, and hopefully it gives you a good experience of all the different ways to do things. Last name and bye-bye. Hey, 12:51. I nailed it. Tomorrow, you get to do much easier stuff. So if you're thinking you've had a hard time for the last few days, you probably have. But on Wednesday, things will be a little bit nicer. And tomorrow, poor Chloe goes and gets her cone of shame operation. And so I will be here, but I'll be even more distracted because I'll have the guys on the roof, and she'll still be recovering from her operation, but I'll be worried about her. So for that reason, Maggie is taking over tomorrow. So I'll start the questions, and then when I lose the place, she's going to jump in. Mia, your job is to mention anytime I do a question that needs a U sub. Christian, you're in charge of numbers. Matthew, you're just in charge of everything else that I screw up, right? And between the 5 of us, we probably will get through tomorrow, right? Christian, you don't look like you're too chuffed about the job I gave you. Did you want one of the other jobs?
Is there one where you can just sit here and look pretty? Can I be in charge of that one?
Oh, Christian, I'm going to have to insult you because you did set yourself up. There is no way that's going to happen. I'm sorry. Sitting there and looking pretty is not one of your strong points. Sorry about that.
Oh, man. All right.
Oh, God.
Yeah,
I get paid money to insult students. Isn't this a great job? Yeah.
It's definitely got to be a fun job at times.
It is. Matthew, are you ready to take over tomorrow? Just to keep everything in, are you sure that X is an X, right? And should that not be pointing the other way or whatever else happens? So the poor little thing, she's going to be, we're worried about her because she's a nervous little soul at the best of times. And I think that's a bit of a stress for her. Okay, bye-bye, guys. Any questions? Otherwise, I'm out of here.
I have a question.
Yes.
So when you asked us to pick the very first U and V values, how do
Mhm.
you determine which one gets to be the U and which one gets to be
Oh, the
V?
good news, it doesn't matter.
That's good news.
Right. I mean, your answer, your working will look different, but the destination will be the same.
Okay, thank you.
Right.
Real
Eric?
quick question. When you were
Yes.
trying to find the equation of line A, you had y is equal to negative x plus 2.
Yeah.
Couldn't you just add x to both sides, get y plus x is equal to 2, and because v is equal to y plus x, you could have just said v is equal to 2.
Yes, I could have, Eric, and that would have been so much easier to understand. But I
Yeah,
had a
perfect.
guy at the top battering lumps out of the roof, and my brain was just not focusing.